Okay, so hi everyone. So as you know, this meeting is recorded and will be uploaded to YouTube. I guess we can start with the items listed under our agenda. So Vinay, if you want to discuss the in-place pod vertical scaling, please go ahead.
Yeah, sure. So it's been some time since I've talked about this. So a short overview of this is that the desire, what we intend to do here today, we cannot resize the pod, as in change the resources field in the pod spec without restarting the pod. It's disallowed by the validation check in most cases. And the intent of this cap is to make that mutable and then have a mechanism in the core Kubernetes to handle this change and drive towards the desired new resources that the user desires. That's the desired state. So in doing so, a little history, our first design was keeping scheduler in the loop, where scheduler would first look at the request and then approve, reject based on its view of the node capacity. And then the kubelet would act on what the scheduler approved. This, the SIG node felt was overly complicated to manage. So, and Direct felt that once the pod is bound to a node, the resizing should purely be a discussion between the API server and the kubelet. And scheduler can potentially help if by preempting lower priority pods, but that is something we plan to take up in the future. It's not part of this cap at this time. So once the pod is bound and a resize is requested, kubelet looks at it and decides whether it can accept it or not based on the available capacity room in the node. And if it does, then it indicates that by updating a new field that's been added to pod spec called resources allocated, which is the requests part of the resources, and says, okay, yes, I have room. I take this resize request. So it essentially allocates the capacity for that pod. And if there are any changes to the limits, it drives towards updating the limits for the containers that belong to the pod. This is pretty much the short summary of this. And yeah, one more thing, that resources, there's a new field in the pod container statuses called resources allocated, which is, resources, which is what the final state is. So scheduler's role at this point is purely as an observer. It essentially gets updates. Pod updates are taken in, and it updates the resources allocated section of it when a resize has been accepted. And the change to scheduler here would be to start using resources allocated instead of resources to compute the pod's resource requirements. And once a new pod is being scheduled, it looks at the existing pods, looks at the resources allocated field, and then computes what's the total capacity, that total resources that's already been allocated on the node, and what's available on the node. And if there is room, it selects the node as a potential target among other predicates, and finally makes a decision based on this. So that is pretty much the change it's contained in terms of what the scheduler is expected to do here.
Just to reiterate and make sure that I understand. So this scheduler actually will look at exactly the same way we're doing right now when we admit the pod, which we look at the pod resource request, like resources.request, I guess. That's the exact field.
Yes, for a new pod, yes.
Only for a new pod?
For pods that are not bound, that the scheduler needs to find a node for those, yes. For the pods that have already been bound, it would use the resources scheduler pod spec containers resources allocated.
Right, and my point is, pods that are not bound are the pods that we are trying to schedule. So for any pod that we are trying to schedule, we will always look at its resources.request to decide where to place it.
Correct.
But to compute how much resources a node is using, we will iterate over the pods on that node and look at the resources allocated field.
Correct.
Right. Okay. So and this is what you meant by like bounded pods. For bounded pods, we look at resources allocated. And those bounded pods, we don't schedule them. We just look at them for calculating how much resources we're using on a node.
Right. Today, all it does is updates the cache when like things like annotations, something changes, it just updates the pod, I believe. This would, in the change would be to, in its accounting, this one field, resources.requests resources.requests would be something that the user desires. So that may not necessarily be what the kubelet has agreed to. So the
Right.
the computation should be based on what kubelet has agreed to. And for a brand new pod in the API server, early at the pod creation time, we'd set this if it is empty. And the current thought process is that if the user sets it at creation, we validate that it should be equal to requests. If not, we fail the validation. And this, I'm bringing this up because David Ashpole suggested there might be a use case. He can potentially see a use case where the user might have a resource allocation for a new pod be lower, and we want to drive towards the resize after it's been scheduled. That's not considered today. I just want to keep it simple for now.
Right, and actually the case that David Ashpole proposed could also, I don't know, could also be useful for next, like the second item on the agenda, approaches to how inform the scheduler of other compute workloads. So you could use that as a hack, basically, to request more resources, to preserve more resources on the node, but actually use less. But let's defer that for the second, for the other.
Yeah, I think that requires more thought. It's nice to have. I kind of see it as, okay, this gives the user a way to say, hey, this is my ideal resource requirements, but this is the minimum for brand new pod. And schedule me at the minimum, and if possible, drive towards ideal. That could potentially be a nice to have once this is in and we see how this works, how well this works, we can take that up.
Right. And has there been any pushback on the fact that you're introducing a field to a spec, but the user can't actually set a spec field? Like, to me, that sounds a little bit strange.
I don't know yet. So I realized a couple of weeks ago, just before we kind of got consensus that this is the way to go with SIG node, that we need to do a review with the SIG architecture for API review. And I have requested the API review. I'm planning to try and schedule that in the next few weeks. Just wanted to, before I went to them, I wanted to make sure that we cross our T's, dot our I's kind of. So the key impacts here is to Kubernetes SIG node, which is kind of looking like they're going to agree to it, and LGTM. I already got one LGTM by David, but Derek and Don have to approve this. SIG auto scaling should have no issues. I'm going to talk to them on Monday when it's their meeting, weekly meeting, and SIG scheduling, which is we have to agree that this is not going to be a problem for scheduler. Once we have all these, it'll be a strong case for me to talk to them.
So Bobby looked at this way before us. From my point of view, I think it's fine. This approach is way simpler. Way simpler, and I think we can easily integrate it. But I will leave Bobby to comment on this.
So the only concern that we have with this approach is the possibility of race conditions between scheduler and other components, like namely VPA, because it can obviously race with the regular scheduling flow of the scheduler as well as preemption. So once a pod is preempted, a node may look like it has some free resources. At the same time, scheduler wants to use that resources, so VPA may or kubelet may think that that resource is available. Similarly, a certain amount of resource may be available on a node. This is actually what I'm talking about right now, is about the regular scheduler flow or scheduling flow. So certain amount of resources is available on a node. VPA and scheduler both at the same time decide to use it, one for increasing the resource requirements for a pod, the other one for scheduling a new pod. So there are these concerns. I guess at some point we decided that these resources, these kind of race conditions are unavoidable in large distributed systems. We should, instead of trying to solve them, we should accept their existence and try to resolve them after they happen. For example, if the scheduler assigns a new pod to the same node, the node or the kubelet can reject that new pod. And similarly for preemption, the same thing can happen. And a kubelet could potentially reject the pod, and the scheduler could retry. I think this is slightly worse. This approach is slightly worse for preemption in particular, because the idea here is that preemption happens for higher priority pods, and if the scheduling of a higher priority pod is rejected, it could potentially cause more trouble for users who are expecting these pods to be scheduled maybe as fast as possible or with a higher guarantee. So there are some of these concerns, but in practice we should see. We don't expect these to happen very frequently. As a result, I think this new approach is fine.
Thank you, Bobby. Yeah, that's correct. In fact, our first implementation that I used for demo in Barcelona KubeCon was based on scheduler avoiding this race condition between the scheduler new pod scheduling and resizes. However, the thought process is that this should be a fairly unlikely rare event that the overall system load, and there's no way to know this until we have something in production. It's a chicken and egg problem. And once we have something that's in there and is used in large scale, then we'll have the data to determine, okay, maybe we should update our implementation to have scheduler in the loop. That's something that I could not justify with data without having the data, because there's no way to get the data. And the system kubelet already does this today, because you have multiple schedulers, and there is a race condition inherently built into that. So this is in one way to look at it is this is an extension of the already present race condition between multiple schedulers.
Yeah, one thing to note though is that these kind of race conditions are somewhat rare in the Kubernetes world, because most of the times in Kubernetes, Kubernetes clusters are created in cloud environments. The assumption is that there is plenty of nodes available for all the workloads in clusters. As a result, most of Kubernetes clusters do not have a ton of pending pods waiting to be scheduled. In on-prem clusters, the story is completely different. For example, in Borg, they almost always have a ton of pending tasks in every cluster. When there are so many pending tasks or pending pods in a cluster, potentially these kind of race conditions can happen more often. So we should see in practice, and then based on feedback, we can of course redesign.
Yeah, this feature actually helps in that there was one of the cases that there's a company called JD.com which used our first implementation, and they found that if they see a lot of pending pods, they go in and see what pods are not really using their capacity, their allocations, and they size them down, and that way they get more work running.
Right.
So this feature can help.
Correct. Absolutely. When it comes to downsizing, absolutely, this is actually super valuable.
Okay, sounds good. I think
Yeah, one thing I want to bring up is that, so it sounds like scheduler needs to be aware of every update of the bound part, right?
It it doesn't need to be. Ideally, it would see the update to resource allocations before a new scheduling decision is made. But since we're using the cache, you cannot guarantee that's going to happen. You cannot
Yeah,
time series them.
my point is that to make the internal scheduling cache always update to date, so we need to be aware of every update of the part, right?
Yeah, we
Yeah.
already watch for pod updates, right? Like, so when a pod update happens, we're going to look at the resource allocated. If changed, then we update the cache.
Yeah, so right now, since we, maybe I'm wrong, I think our code base just watch on the pending path, which means the node name wasn't being set. That's
No.
my impression.
No, it watches all pods, including the pods that have been scheduled. For the pods that have been scheduled, it just updates the cache. It doesn't act on it. There's no predicates or any work done in the scheduler. It's a simple update function and exit. Remove old pod, add new pod.
Yeah, I know that. I just need to check the code whether we already have the update group on that, or it's newly added. If it's newly added, we need to be aware of the overhead. That's my point.
Sure. Yep.
Okay. We have 10 more minutes, so I'm gonna give some time to Nick to discuss approaches on how to inform scheduler of other compute workloads.
Thanks. So my ideas are not very formalized. I didn't go to SIG first. So the problem that we have is we have an existing VM scheduler, and it's scheduling VMs on a set of physical nodes. And we were looking to add Kubernetes to that management plane, but I think it'll be a long time before we switch the scheduler of Kubernetes to schedule the VMs. And I was wondering how we can have these two systems coexist.
What do you mean have the Kubernetes scheduler schedule the VMs? Are you going to have your VMs as well?
If you look at like KubeVirt, where KubeVirt schedules, they take, I think, pods to schedule pods, but they create the VMs inside the same namespace as the pod.
Okay.
But if we scheduled the VMs outside of Kubernetes and we watched Kubernetes resource allocations, we also want to be able to inform our resource allocations back into Kubernetes. And I was curious how to accomplish this. There's a few things I saw. I could create pods that didn't do anything, that were specifically bound to nodes, then watched for preemption and shot the VMs based on the priority level. Or I could update the root reserve of the VM usage, but that's a recycle of kubelet. So I was curious if SIG scheduling had a way of informing CPU and memory utilizations on the node that's dynamic, but it doesn't change often, but changes occasionally.
So the scheduler of Kubernetes does not know anything about the actual resource usage. If you're talking about the
it's not usage. I want to update its like a reserve amount, not dynamic usage, but reserve.
Well, yeah. So one thing that was not I'm not fully familiar with your problem, but one thing which was not super clear to me was that whether the fact that your VMs are like pods for Kubernetes.
So if you look at KubeVirt solved this problem by scheduling the VMs using, by scheduling pods. They created a VM CRD, they scheduled a pod, and that pod represented the resource allocation of the CRD. And then when the pod was scheduled, they actually created a VM in its place.
I see. So essentially, from the scheduler's point of view, those VMs are pods.
Yes. I was trying to understand if if I didn't do all the scheduling through Kubernetes, how could I backchannel inform Kubernetes about these? One idea I had was create pods that were assigned to specific nodes that represented the resource utilization that were empty.
Yeah.
I wasn't sure if you had any other suggestions potentially on how to approach this problem.
Yeah, that's one way of doing it. In fact, we have something, a concept similar to what you just described called mirror pods. Those are used for to represent the node usage, the node resource usage, and basically create a sort of like a representation of static pods that are created directly on nodes. And then these mirror pods are created to represent their sort of like the logical object, and they're stored on the API server. We actually recently, we felt like these are not great because there are some problems with respect to like race conditions when these pods are created on the nodes versus the mirror pods are created on the API server and whatnot. But generally they work. They are not, of course, as great as just regular natural pods, but that's one way you can solve this problem.
But how is this different from creating from what he's proposing?
So this is I think, as far as I understood, this is very similar. Basically, they want to create.
This sounds very similar. This is an interesting avenue that I can pursue. So
yeah, this is you can take a look at mirror pods.
Okay.
That's one way of kind of representing these. If you want to take a look.
What is the downside of using what you just proposed? Because a pod, from our perspective, represents the resources that we are reserving on the node. So, to me, it sounds like a logical solution. But how are you going? Are you going to create the VM not from the pod? You're going to have create the VM via like an external.
So I was creating the VM externally. I wasn't sure if there was an easy way to potentially create the reservation before I realize it and flush that cache all the way into the scheduler, such that the scheduler could approve or reject. And then the only way I thought of approving or rejecting was probably just scheduling a pod. And we do have preemption and priority levels, and we could watch.
Is that VM part of Kubernetes node or it's not?
It's placed on a Kubernetes node.
Okay. So you're basically creating a pod that requests all of the CPU for that node, but that pod doesn't run on that node.
Well, I have workloads that run on nodes that aren't represented in Kubernetes, and I don't want them to be bound by the system reserve. I want them to be able to dynamically share the same space as the Kubernetes scheduled pods.
I mean, the logic, like a node is an abstraction, right, from Kubernetes perspective, and it's how we represent the amount of resources of a single entity, right? So to me, the most logical way is to define what that node represents, whether it represent half of the resources of that physical host or all of it. So and if you represent, for example, all of it, then you are practically saying that Kubernetes can use all of that resources to schedule a pod. So
yes,
if you don't want to do that, then you really need to configure the node object that represents that physical host to consume half of it or whatever amount of resources, such that you keep enough for other system to schedule workloads on that node. So from my perspective, it is more of a flag or some configuration to the kubelet that configures how much resources you want to give it, rather than the other way around.
Well, I want them to be able to share the same space. And I understand that means that Kube Scheduler can schedule all of it. but I want to periodically, or I want to schedule some of it and then inform the kube scheduler that its amount of reserve has changed.
Right. Then in this case, then it's the mirror pods.
Okay.
Key use case.
I will look at that concept. Thank you, guys.
So one last action, one last item on the agenda is I wanted to pick your brains on what is the safest way to migrate our predicates priorities into plugins in this in the framework. So one idea we discussed with Aldo with Aldo and Chong here is that we would like to have a feature flag, a new feature flag that will allow, while we are migrating predicates and priorities into plugins, we will have, for example, for a specific predicate, we will have its implementation as a predicate and its implementation as a plugin. And the priority flag, it's a single flag. We will either say, well, I'm going to use predicates or I'm going to use plugins. So that the reason is that we, like for some of the logic will be just copy paste, but for others it might not be, because we're going to have to split it into different extension points. So just for the concerns of safety, the idea is to have a feature flag and graduated alpha, beta, etc. And it will be in GA only when we basically have everything converted into plugins. I don't know if you guys thought about this before, or you think that this is completely internal logic, we should have full control over it, and we can do whatever we want. So take the risk, basically.
When we designed the scheduling framework, that was my impression, that these are all internal logic of the scheduler. At the same time, we need to still keep the mechanism to disable some of these via the existing policy config of the scheduler. So basically, we should, since that policy config existed, we need to be backward compatible. And if a particular predicate is disabled, or if a particular priority function is removed or its weight is changed, we need to apply those changes to the plugins. But other than that, I don't see any reason to keep both at the same time. What are the concerns that you have that you think that we need to keep both?
It's the magnitude of the operation that we are undertaking. There's a lot of code that are going to be moving around. And
it's pretty much the old scheduler.
Pretty much, exactly. So it's a huge restructuring of the scheduler. And it's just for me to sleep, basically, like make sure that nothing is...
No, I understand. To be honest with you, very early plan was to build a second scheduler, call it scheduler 2.0.
Okay.
And keep this scheduler in its own repo and build the scheduling framework in parallel. But later on, I felt like it'll be almost impossible to roll out a scheduler 2.0 if we don't build the framework into the existing scheduler. So we decided to basically build the framework into the existing scheduler, but I understand that there are a lot of concerns. Similarly, there were a lot of concerns with preemption. I remember that I got quite a bit of a hard time when we were rolling that out. Everybody was freaked out. People were thinking, oh, billions of dollars of workloads are in danger and all. So I understand your concern. So it makes sense if it really makes it much more reliable, reasonably. Then yeah, I would say why not? Let's have a flag and graduate once we are confident.
I have one question with regards to predicates. Hi, this is Maciej. Wouldn't you consider predicates being somewhat API of the scheduler for the people consuming those and setting the scheduler based on the predicates?
They have never been APIs really, but I mean, if you're talking about autoscaler, yes, scheduler has worked with autoscaler, but other than that, predicates and priority functions have never been API of the scheduler. Basically, their internal logic has never been a concern to the users.
There is, as part of the migration plan, we will be moving the predicates into plugins. But I have a section in my doc to present a reasonable way of cases like cluster overflow, or even daemon set controller to consume those filters. We're not just gonna cut it and basically tell you guys, deal with it. We will collaborate on that part, and we're not gonna remove those functions until we're sure that everybody has moved into a reasonable state.
I mean, I'm just putting a log information that you are using outdated predicate that is moved to plugin these days. This is how you should be migrating.
Yeah, that's
efficient, but yeah, I would still put it just for the sake of informing users about the moves.
Mm-hmm. Any other comments or suggestions? Okay, sounds good. So before the next meeting, I'll be sharing with you guys all my thoughts on the migration. It took a while because it basically pretty much read the whole scheduler code during that process.
Is there going to be a KEP or a doc or something?
So it's a doc that will probably convert into a KEP. The core part of that KEP is going to be really deprecating policy config. If we deprecate
the policy config that scheduler takes, right?
Exactly. And if we deprecate that, we're practically deprecating access to predicates and priorities, which means everybody has to use plugins, etc. And as part of that, we have to make those available as plugins through the component config.
Right. So again, this is I'm not very familiar with it. So plugins are basically going to be core, like compiled into the scheduler in the core Kubernetes, right?
Correct. Yeah.
Okay. And then, so when we disable predicates, is there going to be a one-to-one flag for each plugin that we enable will disable a corresponding predicate or something like that?
No. So as we mentioned, this is practically internal logic. As long as we're able to support the policy config API while it's being deprecated, then we're fine. And the flag that I was mentioning is just basically a generic way of switching between the old implementation and the new one.
Right. But I mean, basically, we are trying to move the predicate to the plugin, right? So both cannot coexist, right? You cannot. Okay.
They cannot run at the same time, but they can coexist in code.
Yeah, sure. They can coexist in code, but they can't be enabled at the same time.
Got it.
Yeah.
I have one comment about the Nick's approach problem. Are you looking to use one reservation pod per VM, or?
I think Nick.
I think he has left.
Okay, just the comment was that this is going to count against the pod limit. That might affect how many pods could run on the node.
That is true, although, yeah, I don't know. You're right. Hopefully, they're not going to run into everything.
Yeah, unlikely.
Right, and also using some resources like that they will not use, for example, pod IPs. They're going to go two ways, basically.
Right.
Anyways. Okay,
that's all I had. So with regards to my KEP, if this looks good, please LGTM it. If there are any questions, I'll answer it on the discussion thread. I know Klaus has a couple of questions I've answered. Hopefully he's gonna look at it and
Sounds good.
resolve.
Okay.
Thank you.
We are 8 minutes over time. Thank you, guys. See you next week.
Thanks. Bye.